For those who watched my last video about Uranus, this time we're looking at another outer planet in our solar system, but unlike Uranus, which is an ice giant, this time we're looking at a gas giant with the most compelling rings of all, Saturn.
Nice.
When it comes to Saturn, the first thing that comes to mind is almost certainly its rings. The rings which make the planet so well known are composed of stunning groups of ice particles, rocky debris and dust. But did you know that apart from the rings, Saturn also boasts one of the biggest mysteries in our solar system, the spinning hexagon? We first discovered the six-sided jet stream when the two Voyager spacecraft passed by Saturn between 1980 and 1981. At that time, their trajectories prevented them from capturing a single image of the entire hexagon, which is twice as wide as Earth from above. Their flybys only offer glimpses of its edge. It wasn't until 2009 that the spacecraft Cassini examined the hexagon and captured images in unprecedented detail showing the symmetric jet stream. The images captured show that the jet stream is about 20,000 miles across, with winds reaching 300 miles per hour. We also discovered that this hexagon spins around a tight vortex that marks Saturn's north pole. This hurricane-like vortex has an eye which is about 50 times larger than the typical Earth cyclone, with maximum wind speeds about double those of the strongest cyclones we have seen here. It's important to remember that although this hexagon vortex resembles a hurricane or a cyclone, it's not the same because hurricanes or cyclones on Earth feed on water and heat from Earth's surface, which is not the case on Saturn. However, this hexagon vortex does share the structure of a hurricane or a cyclone. The hexagon itself is one of the biggest mysteries of Saturn's dynamics. Its size and angles are roughly symmetrical, and for people like us who are accustomed to weather on Earth, such an ordered geometric pattern just seems very curious and alien. But then again, maybe Earth is the oddball. Here on Earth, we have sunlight that drives wind and weather patterns when we are nearly 10 times closer to the Sun than Saturn, which means that we receive nearly 100 times more sunlight than Saturn. Earth's surface is also a lot more diversified than that of Saturn, with water, land, ice, and snow all heating and cooling at different rates. So Saturn receives much less sunlight and has a much more uniform surface, which leads to a completely different weather system. Earth also has an extremely shallow atmosphere compared to Saturn's and has towering mountains that reach miles into the sky and disturb atmospheric flow, something Saturn doesn't have. What I'm trying to say here is Earth lacks the condition for a jet stream to settle into a symmetric shape, but Saturn is different. It has no solid surface, its composition is far more uniform, and sunlight may not be the only driver behind its weather system due to its greater distance to the Sun. At present, we still don't know exactly what caused the hexagonal cyclone on Saturn, but we have managed to duplicate the hexagon in the lab on Earth using the cylindrical tank of water on the slowly rotating table. What's interesting here is scientists have also produced other shapes such as squares, octagons, and other polygons depending on the speed and the properties of the fluids that was used. So hexagon wasn't the only result scientists have seen in this lab experiment. Despite having produced this hexagon in the lab on Earth, scientists still haven't figured everything out. For instance, why is this hexagonal jet stream only available in the north, not in the south? And why is this cyclone-like vortex so long-lived? Because cyclones on Earth typically last a week, but this one on Saturn has been there for decades, if not centuries. A high-resolution view showed a wide variety of cloud structures within the hexagon. Here we see a massive cyclone tightly centered on the North Pole, and there are also numerous small vortices appearing as reddish ovals. Some of them spin clockwise, while the hexagon and the center cyclone spin counterclockwise. We also note that some of the smaller features are swept along with the jet stream of the hexagon, as if on a racetrack. We don't have an answer as to why they behave in this way. The hexagon even changed color as Saturn's year progressed from spring towards summer. As the North Pole heated up, we see a bluish-green change into a yellowish haze as methane molecules breaking apart in the atmosphere into hydrocarbon particles, a process very similar to the formation of smog on Earth. Cassini's orbit around Saturn also measures gravity, revealing that high winds as Saturn's cloud tops extend far below to 5,000 miles towards the planet's interior. And researchers have used this finding to suggest that perhaps a supersonic jet stream is pinched on all sides by smaller cyclones pushing upward, forming the hexagon. So after Cassini's 13 years in orbit around Saturn, scientists still have commented that the mystery and extent of the hexagon continue to grow, and there is still much more for us to uncover about this great mystery.